All right, everyone, it is 7 o'clock, so let's go ahead and get started. All right, so I'll first go over some of the things that were covered in the class material for this week, and then we'll talk a little bit about the assignment that's due on Tuesday night. All right, so the first thing that was covered in the course material is about updating variables. So at this point, you should know what a variable is. Let's just say we have the variable x, and we assign it a value, right? Let's just say the x is the value 12, right? We print that out, the value x, then we should just get 12 printed out, right? We run it, and there it is, 12 is printed out. So updating variables is very simple. Updating variable is just changing its value, right? So right now, x is 12. Well, we can update it by saying x is x plus 1, right? So I'll say right here, x is the value 12. Here, we're going to say x is equal to the value x already is plus 1. So at this point, x should be 13. Let's run that. And sure enough, the answer is 13. You can do this again and say x plus 10. Now it should be 23, right? Let's run it. And there it is, 23. So that works with these, which are integers. It could also work with floating point numbers. If this was 12.1 and we still kept the rest of this, it should be like 23.1 at the end. We run it, and there it is, 23.1. So that's easily how you update the value of a variable. It also works for strings. So if x was ABC, we just print that out. We're going to get, oops, close my file. Let me open the file back up. Not that one. File, open file. There we go. So we just say x is equal to the string ABC, and then we print x. We run that. Of course, it just prints ABC. But we can also update that variable, meaning x equals x plus, say, DEF. Right? Now, if we run this, the total string should be ABCDEF. Run it, and sure enough, there it is, ABCDEF. So that's how you update a variable. And you don't have to just add to it. You can just completely reassign it. So if we only have this, x equals ABC, we can just say it equals XYZ instead, right? Completely changing its value, not even being dependent on what it was before, just assigning a completely new value. We save that and we run that. Of course, we're going to get XYZ printed out. So that's just what we mean by when we talk about updating variables is you assign an initial value to a variable, and then at some point you can change the value to whatever you want it to be. So that's really all there is to updating variables. Just a quick little thing that was supposed to be at the beginning of this week's lessons. So let's talk about loops. Now we're starting to get a little bit more complex. And at any point, you can go ahead and stop me and ask any question if you want as we go through these. But let's talk about a loop. So the first loop that was in your material for this week is the while loop. And here's what it looks like. We have the word while, and then here, just put some underscores right now. Here we have some condition, and then we have a statement. Statement. And I'll talk about what these are in a second. Statement. Etc., etc. You can have as many of these statements as you want. What I mean by that is here in this blank space, you're going to put some kind of mathematical operation, or you can use the word true. We'll actually talk about true in a minute, but you put some kind of mathematical operation here. So let's say we have a variable x is equal to 1. Okay. Now what happens in a while statement, we'll say while. We'll have some kind of mathematical comparison here. If that mathematical comparison is true, all of these statements will get executed, and then it'll come back up here and it'll check it again. If it's true again, it'll run all of these statements. After it runs the statements, it'll come back to the top, it'll check this again. As long as this keeps remaining true, it'll always execute this. After a while loop, as soon as this is not true, then it skips all of these and goes after the loop. So what we're saying is, while this mathematical statement is true, do these statements and then loop back up here and check again. So for example, let's say while x is less than, say, 10, okay? So what's going to happen here? So at the beginning, x is equal to 1. We do this while, and we do this check. Is x less than 10? And the answer right now is yes. It's true because right now x is 1. So because this is true, it's going to execute this first statement. So let's just have it be print. We'll just print out what the value of x is, right? And let's have that be the only thing it does right now. And then here we're going to just print after a while loop, so that we know whenever we see this printed out, we know the loop is over, right? Let's save this and let's think about what's going to happen. So x is equal to 1 while x is less than 10. So right now x is 1. That is true, so it'll print 1. Then it'll go back to the beginning of the loop. While x is less than 10, it's true because x is 1. It'll print 1. So what this is actually going to do is going to print 1 forever. The reason why it'll print 1 forever is because x is always equal to 1. I never changed the value of x. X is always 1, and so 1 is always less than 10, and so it'll just keep printing this over and over and over. So let's run that. See what happens. And sure enough, it's just printing 1 repeatedly for the end of time, right? All right, let's break it. So what we can do here, let's say we want to change the value of x. Let's say x equals x plus 1. So now what's going to happen? So at the beginning, x is equal to 1. While 1 is less than 10, that is true. We will print the value 1. And now x will be 2 after this, right? So then it'll come back up here. X is now 2. 2 is less than 10, that is true. So it'll print the value 2. And then this line will get executed. X will now be equal to 3. It'll come back up here and check it again, and so on and so forth. At some point, we're going to get x to be equal to 10, right? At some point, x is going to be 9. This will make x 10. It'll come back up here to the loop. Then it'll check while 10 is less than 10. But that is false. 10 is not less than 10. It's equal to, but 10 is not less than 10. So once we hit that point, it's going to skip these statements and just go directly to after the while loop. So what we're doing is we're going to be showing it count from 1 to 9, actually. And let's watch that and make sure that's what happens. Sure enough, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go to after the while loop. Let's say we actually wanted to count to 10. We want to include 10. Well, we could just say x is less than or equal to 10. That means, you know, when x is 9, we print 9, then x turns into 10, and then it'll say while 10 is less than or equal to 10. That is true. So then it'll come down here and print 10. Then x will turn into 11. It'll check it again, and 11 less than or equal to 10 is false, so it'll skip over it. So this will count all the way up to 10. Let's run it. And sure enough, there it is, counting 1 through 10, and then it says after the while loop. So we know that the loop ended, and this is where we got to. So that's basically all there is to the while loop. Now, you can have almost any mathematical comparison you want here. You could have x is greater than 10 or something, right? So, you know, our math operations, we can have less than, we can have less than or equal to, got greater than or equal to. We got not equal to. Of course, you would have a variable here and like a value here. And this will run while x does not equal 10, right? Let's run that. What do we think is going to happen here? This will actually count from 1 to 9. And the reason being because x starts as 1. We're going to loop while x is not 10. We'll print out what x is, and then we'll make x go up by 1. So I'll just count from 1 to 9. And it does. Counts from 1 to 9. And it says after the while loop, so that we know the loop ended. And, you know, we got right there. That's all there is to the while loop. Now, by accident, I actually showed you what an infinite loop was. Remember when at the beginning I said while x is less than 10, but I didn't change the value of x? That means this is what we call an infinite loop, meaning this loop will never end. And the reason being is because we're checking if x is less than 10, which is true at the beginning. And so we print that out, but we never change the value of x, so x is always 1. So 1 is always less than 10. And so it'll always just execute the statement and then go back to the loop, meaning the loop will never, ever end. It's an infinite loop. Another way to do an infinite loop is you can use the word true here. True, and it has to be a capital T. You can't do a lowercase t. Do a lowercase t, Python doesn't know what you're talking about. It has to be an uppercase T. So you say while true, print x. And we can even put in here x equals x plus 1. It doesn't change it. It's still an infinite loop because this true is always true. So every time it comes up here to check this, true is always true. So if we run this, it's actually going to count starting at 1, and it'll count forever. Because every time it checks this value, true is always true. It's never false. Let's run that. And you see it's counting up really, really fast, but it's counting up, it's going to count forever. And the only reason why it stops is because I forced my computer to stop that program. So that's an infinite loop, meaning it goes on forever and ever and ever and never terminates. All right, the next thing we have is the for loop. But something we need to talk about before we talk about the for loop is a list. We'll call a list in Python. Unfortunately, I don't think the course material does a good job talking about lists, at least not before you have to start using it for a for loop. Let's talk about a list. So just like we have this variable x equal to the value 1, let's say we have a bunch of values. We can represent them with these square brackets right here. This means this is a list of items. It's more than one value. Right now it's empty, meaning there are no values, but we can give it values. We can say 1. That means x is equal to a list, but the only thing in the list is the value 1. If we want to add more, we can have 6, 2, 10, 34, ABC, 98, whatever. That means x is a list of values. It's more than one value. It is all of these values. Or more likely, it is a list that contains all of these values. And the first value is a 1. The second value is a 6. The third value is a 2. The fourth value is a 10, and so on and so forth. And they don't even have to be the same type. As you can see, I have integers here. I have a string here. These can be floating point numbers too. It doesn't matter. They can all be different types. But now this variable x is not just a single value anymore. It is a list of values. So what we do, we actually do print. If you remember, we have type x. This will tell us, if I spell it right, this will tell us what type of variable x is, and it should print out a list. We run it, as you see, it is a list, right? So why is it important to know this? It's important to know this when we start talking about for. The for loop. Just like while was a way to loop your program over and over and over, a for loop is also, but a for loop is useful when you have a list of items and you want to do something to each item in the list. So let's say we want to print out each one of these items in the list. We have a for loop. Then we can name something a variable. To make this easier, let's call this items. This variable items is just the list of all of these things, right? So let's say for each item in items. What this is doing, this is making a loop. This is the list that we are going to loop over. Items is the list we're going to loop over. And item is what we are going to call each one of these. And let's say we want to print them out, so we can print the individual item. So what's happening here is the first time in this loop, item is the first thing. When it loops again, item is the second thing. When it loops again, item is the third thing, and so on and so forth throughout the whole list. So it's a for loop, meaning we use the word for. This is the list that we're going to loop over, and this is what I want to call each item in the list. And it doesn't have to be called item and items. This could be called AAA, and this could be called A. Right? That's fine. The name of the variable does not matter. It can be anything you want it to be. Usually it's good to name it something descriptive. That's kind of why I can name it a list of items, right? And I just have to make sure it matches up, meaning this variable is a list of items. That's all in this list. So I'm going to loop over this list of items. I want to call each one this item, and then I want to print out this item. So if we save it and run it, what's going to happen is it's going to print out each one of these one at a time. Let's run it, and sure enough, there we go. So the first time through the list, this item is 1, so we print out the 1. The second time, this item is 6, and it prints out 6, and then 2, and then so on and so forth. So that's how we do a for loop over a list of items. And these really don't ever go to be infinite, and the reason because you can't have an infinite list. You have to specify what is in the list. So a list is never infinite. You know, it has a specific number of items in it. And this is just saying, like I said, for each item in the list, do this with the item. And we can do anything we want with it. You know, it doesn't have to be just print. We can say do math with it. We can say x equals this item plus 7 or something, right? Whatever we want to do with it. And then let's say we want to print x. Now we do have to be careful, you know, because if we want to say each item plus 7, well, that makes sense for all these numbers. It doesn't make sense for this string, right? You can't add the number 7 to a string. That doesn't make sense. So actually, if we run this, it's going to work until it gets here, and it's going to crash. You can just see that. You can see here, you know, it did the first few numbers correctly, 1, 6, 2, 10.12, 34, but then it got to the string, and you can't add a number to a string, so that's when it crashed. So if you do something in here, you have to make sure it makes sense for all those items in the list. I mean, if this was a number, say 99, now we run it, you know, it's not going to crash now because for all of these items, it makes sense that you can add 7 to it. Okay, so that's your basic for loop, and that's what a list looks like. I think not next week, but the following week, I think we'll start talking more about lists and other stuff you can do with lists. But for right now, this is all you need to know about lists. You can name a list any variable. This is how you say what a list is. You have these square brackets, and inside you have each of the individual items separated by a comma. And then that's how you loop do a for loop over every item in the list. Okay. So let's look at a couple things we can do with a for loop. So let's say we want to count how many items are in the list, right? That might be useful. So how will we count how many items are in the list? Well, we can have a variable, let's say C. We'll start it off to be 0. So for each item in the list, how could we count how many there are? Well, each time there's an item, we can increase the count by 1, right? And then we can print C. That's how many items are in the list. Because C starts off to be 0, and then we'll do this for loop for each item in here. For each item in here, we'll increase the count by 1, and that should tell us how many items are in there. So let's run that. And sure enough, it gives us 7, and if we count it up, 1, 2, 3, 4, 5, 6, 7, there are 7 items in there. So that's how we can do a count. How could we do the sum of the items? We do S for sum. We do the sum will equal the sum plus what? If we need to add up each of these individual items, well, the sum starts to be 0, and for each item, we're going to say the sum is equal to the sum plus this item, right? And then we can print out the sum. Let's run that. And it's 250.12. And if you do the math, you'll see that that's the right answer. That is the sum of all of these numbers. Okay. What if we want to do the average? How will we do the average? Well, we kind of already did the answer. You know, this gives us the sum, but to get the average, you take the sum divided by the count, right? Well, a second ago we did the count. Let's just add the count back in there. Count plus 1, right? So at that point, S will give us the sum of all the items. C will give us how many there are. And then, you know, sum is just, or excuse me, average is just sum divided by count. Let's run that. And that's the average for all of those numbers. That's probably good to remember for your assignment. Yes, that's the average. Let's say we want to find the largest item in the list, meaning we have this list of numbers. Which is the biggest number in here? So let's think about it for a second. So if we go through a list of things, I mean, even outside of programming, how do you know which one is the biggest, right? You look at each one and determine, is this the biggest one that I've seen yet, right? So you start off with 1 and you say, is 1 the biggest one I've seen yet? Well, I haven't seen anything yet, so 1 is bigger than nothing, so 1 is the biggest one I've seen. Then you go to the next number. Is 6 bigger than anything I've seen? 6 is bigger than anything I've seen, so the biggest is 6. Then you go to 2. Is 2 the biggest one that I've seen? And the answer is actually no, because I've seen 6, right? So 6 is still the biggest. Is 10.12 the biggest I've seen? The answer is yes. So now the biggest one is 10.12. And you go throughout the whole thing until you've gone through every single number. And at the end, you have recorded which one is the biggest. So let's kind of implement that in code. So let's have a variable called biggest. And this is going to remember the biggest number that we've seen so far. And at the beginning, we haven't looked at any numbers. All right, we haven't even started the list yet. So there's a word in Python called none. That means it's nothing. It's not 0. It's just nothing, right? Because before we start the loop, I haven't looked at any numbers, and so the biggest one is nothing. I have no idea, right? So then in our for loop, we have this item means the one we're looking at right now. So we can say, this is going back to our if statements. If biggest is none, excuse me, none. That means if we have not seen, if the biggest one we have seen is nothing, then this item is now the biggest one, right? So biggest will equal this item. So the first time through the loop, biggest is none. This item will be the number one. So if biggest is equal to none, and that is true because that's where we started, then we'll say the biggest is equal to 1. Okay, that works. But we also have to consider else. And what do I mean by that? That means if biggest is not none, I want to do this, right? And actually, we want to be an else if. And the reason being is in the first loop, biggest will turn into the number one. So once we come up here again, and this item is the second thing, meaning 6, biggest is 1 at this point. Biggest is not none, right? It does not equal to none. Biggest is the number 1. So now we need to say, well, if the biggest one is less than this item. So what that's going to say is if the biggest is less than the one we're looking at now, then the biggest is now equal to this one. Oops. And then at the end, and we'll run through this, and at the end, let's print biggest, so we can print what the biggest number is. And to show it works, just before we dig into it, you know, the biggest is 99, right? Let's run it, and you can see it does print out the value 99 as the biggest. So let's look at it. Biggest is none. The first time in the loop, this item is the first value, so it's 1. If biggest equals none, that is true, because we said it there, then biggest is equal to this item, which is 1. So now biggest is equal to 1. Okay? We go back up here. This item is now 6. Biggest is still 1. So if biggest is equal to none, that is false, right? Because biggest is 1. So because this is false, it goes to the else statement. And now we're going to say is biggest, which is 1, less than this item, which is 6. That is true. 1 is less than 6. So now we're going to say, okay, biggest is now equal to 6. Okay, so now biggest is 6. We'll look through it one more time. We come back up here. This item is now the next one. This item is 2. So and biggest is 6. So if biggest is equal to none, that is false because biggest is 6. So we'll go to the else statement. If biggest is less than this item, biggest is 6. This item is 2. Well, this is also false because 6 is not less than 2. So it skips it. There's no other statements down here, so it goes back up to the for loop, and then it goes to 10.12, and so on and so forth. So that's how you can get the biggest item out of a list. Conversely, you know, it is very easy to get the smallest item. You know, how would we get the smallest? Well, the only thing we have to do is just change this from less than to equal to, or excuse me, less than to greater than. Meaning we're just doing the opposite mathematical comparison. Instead of saying if something was smaller, we're just saying if something was bigger than it. So I'm not going to go through and change all these variable names, but if we run this, it should give us the smallest value, right? Which is the number 1. Let's run this, and there it is. There's the number 1. So that's how we can get the biggest and the smallest values out of a list of numbers. Yeah, and that is all there is to this week's material. is basically understanding these while loops and understanding these for loops and understanding how to do a for loop over a list of items, right? And what the different structure means and things like that. So that's all for the material. What I'll talk about for the next few minutes is the actual assignment, and let me bring it up so I can have it on my screen. Assignment 4. Okay, so for your assignment, you have a list of 5 students, and using a for loop, you prompt for each of their quiz grades, and then at the end, you print out the average of those 5 grades. Well, actually, we've already done all of that. Not all together in one piece of code, but here this evening, I've shown you each of those steps. I'll give you a little bit of a gimme. I'll give you part of it. So, it says you should compute the average quiz grade for a group of 5 students. Your program should include a list of 5 names. We've already said that this is a list, right? So let's just make 5 names in here. John, Beth, I forgot that. Well, that's enough. That's 3 names, right? So let's delete all this extra stuff. And then just for this example, let's just print out, let's just call this students. It's a list of student names. It's more accurate what it is. And let's just say for each name in student names. And then we'll print out the name. So we have a list. The variable name is student names. It's a list of these strings, these 3 strings. Then we'll do a for loop for each name in this list. Just print out the name. If we run that, it should print out Dan, John, Beth, right? There you go, Dan, John, Beth. But what you need to do for your assignment, you got to go beyond that, obviously. You need to have the user input the quiz grade for each of those students. And in the prompt needs to be the student name. I'm going to leave that to you guys to figure out. As part of the assignment. And then you need to compute the average of all the student grades. I've already given you an example of computing the average, actually. Whenever I post this video online, you can rewind it back and watch that part of the video again. But most everything you need for the assignment has been kind of given here for you. You just need to piece it together and make it work. And that's all the material I have to cover for today. So I will open it up to any questions you have. It can be about the course, the assignment, quizzes, or anything that you like. So the floor is open.
Hi, this is Chris. I have a question about comments. Is it necessary to comment what each piece of code does, or can you put comments like at the top of the code that would explain like what the whole for loop does, for instance?
For this course, I would like it to comments to be at each block of code. And what I mean by that is, say if I was commenting this up, I'd put a comment here that says list of student names, right? Then for this for statement, I would just put loop over each student name, or loop over students and print name. If you did that, you don't need to put print name. You don't need to put that there, because here you've already said what you're doing for this block. Even if I was doing more stuff here, let's say at x equals 0, x equals x plus 1, that's like a counter, right? Here you can still say count number of students and print their name or something like that. So you don't need to do it for every single line, but kind of every section of code. And I understand sections kind of ambiguous, so I'm not grading particularly hard on the comments anyway, but just leave it like that where you're doing consecutive statements that accomplish one task. I would comment those on one line.
Okay, thank you.
All right. I will leave this meeting open for about 10 more minutes until about 7:45. So if between now and then you have anything to ask, feel free to just pipe up and ask. You can also start dropping off whenever you're comfortable to drop off. And like I said, I will have this video posted up later this evening and a link to it posted on the course announcements if you feel like you might miss anything. But as I said, feel free to drop off whenever you want, and I'll hang around about 10 more minutes.
Hello, Professor. This is Mr. Balai. What kind of things are you expecting from code running tests report?
From which report?
Yes.
Do you mean like the test cases?
Yes, sir. Yes.
Okay, yeah. If you go back 1 or 2 weeks, I think it might have been a week 3, it actually gives you an
Week 3.
example of a test case file. And basically, you need to have several columns. One is a test case number, just sequential 1, 2, 3, 4, test 1, test 2, test 3. But then you need to have what your input is, what your expected output is, what the actual output is, and then either it passed or it failed. So, if I was saying doing a program to add 2 numbers together, right?
Mm-hmm.
So the first column I would have 1 because it's the first test case. The second column I would have, say, the numbers 5 and 7. If I ask the user to put in 2 numbers, right? That's the input to the program, is your next column. The third column is, what do you expect your program to print as the answer, right? And so if my input to this was 2 and 3, then my expected output would be 5, right? Because if we do it in our head, if we use a calculator, 2 plus 3 is 5. So that is our expected output. That's another column. The next column is the actual output, meaning whenever I gave that input to my program, what is the answer my program actually gave me, right? And if you did the program right, the answer should be 5, right? But let's say you did the program wrong and it gave you the answer 1 for some reason. It was wrong. Then you have one final column that is pass or fail, meaning, is my actual output the same as my expected output? And if they are the same things, then you can put pass because your program worked. The tricky thing is, if it failed, meaning if I expected my output to be 5, but the actual output is 1, then something is wrong with my program, right?
Yes.
So it doesn't make a lot of sense to put fail, at least as far as what you turn in. It doesn't make sense to have a fail condition, because if it did fail, then something's wrong with your program and you need to go back and fix it. And ultimately, that's the entire purpose of test cases, is to determine what should be the answer and what is the actual answer that my program produces. So those are the columns that you need to have, and you just need to run several tests. So just one more time, it should be the test case number, the input to your program, the expected output, the actual output, and then whether it passed or failed. But like I said, really, if you put fail in the column, then something's wrong with your program and you need to go back and fix it anyway.
Thank you. Thank you. Really appreciate it.
Okay. And that is 7:45. So if there's any last call for questions, I'm going to go ahead and close it down, and then I'll send out a link to the video. Just pause it for 15 seconds. All right. Everybody have a good night.
Good night, bro. Thank you so much.